Welcome to this video. In this video, I'll be showing you how to convert lat-long coordinates or latitude and longitude to UTM coordinates using QGIS, a free and open source GIS software. So the first thing we have to do is you have to understand what is the UTM coordinate system, how it works. I'll open up Google. So we understand what latitude and longitude means. We know that latitude means those lines that run from the bottom of the earth to the top, and so latitude are the ones that run from left to right, and the longitude are the ones that run from top to bottom or bottom to top. And they are measured in degrees. However, sometimes you might need to do some calculations in meters or kilometers, and since these coordinates are in degrees, it will be very difficult to have our coordinates, our results in meters. So that's why we need to, that's one of the reasons why we need to convert from latitude to UTM. So how does the UTM coordinate system work? I have an image here that I've pulled up from Google. In this image, you can see that the UTM system divides the earth from left to right into 60 zones. So each of these is a zone. I'm in Nigeria, and specifically in the western part of the country. So my area falls in the zone 31. If you are in the eastern or the middle area of the country, you are going to fall in zone 32. And if you fall in the extreme area of Borno and Lake Chad, then you are going to be in zone 33. Okay, and we can see that from bottom to the top, the zones are further divided into into different letters from letter C to X. So specifically, I can say that I'm in zone 31, I think N or P. However, this this axis here, these letters are not usually used. The common way of representing UTM is to just get the zone, then decide whether it is in the northern hemisphere or in the southern hemisphere. So if it's in the southern hemisphere, for example, if it is below this 0 degrees line, then it is in the southern hemisphere. So any place below this 0 degree and is in the 31 region or zone is going to be zone 31S. So zone 31 in the southern hemisphere. Then as for me, I'm in zone 31, and I'm in the northern hemisphere. I'm above 0 degrees, so I'll be in zone 31N. So that is the coordinates of my area. This might be a bit abstract, so I found a tool online that helps you get your region easily. So I'm in Africa. I can zoom into Nigeria. I'm in Nigeria. So as you can see, this is my location presently, but the study area is in Kwara State, and you can see most of it is in zone 31. Most of Kwara State is in zone 31. Just a small part of it is in zone 32. So we are going to use zone 31 for our analysis, zone 31N. As you can see, the places below the 0 degree are in they have S appended to the end of their name, to the end of their zone name. So zone 31 S, zone 32 S, but in the north here we have zone 31N, zone 31N, zone 32N. So I'm going to be using zone 31N. That is my UTM zone. Now I've gotten my zone number and the letter. The next thing for me to do is to now find the EPSG code, because that is the way I can tell QGIS about the UTM zone and the coordinate reference system I want to make use of. So I'll go to this site, EPSG.io, is a very great tool. It allows you to search for EPSG codes for whatever coordinates you want to make use of. So I'll type in 31N and click on search. Good. So there are so many results. How many results do we have here? We have 12 valid records and 2 deprecated records. We are not going to be going into the deprecated records. So of all this, there are only 2 that are of concern to me. The first one is this one that has MENA here. The second one is this one that has WGS 84 here. So this is the UTM zone, zone 31, and this also is my UTM zone. They are both useful for where I want to study, but this one is based on the MENA datum. So Nigeria has there's a concept in projection called datum. It's a bit complex, so we won't go into that here. But MENA datum is specific to Nigeria. It was created by the Nigerian government, so for surveyors and geographers in Nigeria. On the other hand, WGS 84 was created, is a generic datum for any part of the earth. It's not specific to any part. So if you want more accuracy and more specificity, then it's better to use the MENA datum, since we are sure that all the points we want to work with are in Nigeria. So we should go for the MENA datum. However, if we are working on a global scale, then it's better to use this WGS 84. At least it is good for the global scale. But if you are working on a specific country, specific region, then it's good to get the datum for that specific country or region. So you can search online to check if your country has a datum system. If it doesn't have, you can use the one of the neighboring country, or just go for the WGS 84 datum. So I'm going to click on this now. Or there's no need to click on it. I can see the EPSG code here, EPSG 26331. So I can just select this and copy the number. Now we are set. So back to our Excel spreadsheets. We have latitude here, we have the longitude here. So we are going to import this into QGIS. Then within QGIS, we convert this lat and the long into UTM numbers. So I have a fresh project here. The first thing I'm going to do is to add a base map. That's going to let me know where I am on the Earth's surface. I'll just add Google satellites. So if you don't, I'll be using Google Maps, sorry. If you don't know how to add a base map in QGIS, I have a video on that. I'll share it in the link or as a card at the top of the video. I'll remove the satellites since I'm not making use of it. Good. So we have Google Maps. I can zoom into my area, my country, Nigeria. I'm sure that all my points will fall within this country. So now I'll go to layer and add layer, add delimited text layer. If you observe at the top here, my file is stored as a CSV, comma separated value, not as Excel XLX. So if you don't know how to do that, you can just, if you got your file as an Excel spreadsheet, or you created the file raw in Excel, you have to save as, and you have to choose here, you are going to choose CSV UTF-8. It's important for you to choose this UTF-8. So there's another CSV. Yes, this is CSV. So I ran into some issues when I was trying to open. I created a file with this ordinary CSV and I was trying to open it in Python. I ran into some issues and it took me some time to figure it out. So I would advise you to use this UTF-8 encoding. So my file is already saved in that format, so I won't be saving it again. Now I want to import this spreadsheet into QGIS. So I'll click on this button here to navigate to the location. My file is on my desktop, so I've selected it. This is the name of my file. Select open. The next thing I have to do is I have to choose the number of header lines to discard. For example, if in your CSV you have a row at the top here that has some information that is not part of your table, then you can add the number of rows that are there. Also, if the first record has field names, yes, in this case the first record has the field names, name, lat. So detect field types, yes, it's good. So it will check, to help automatic, it will try to be smart and check. So for example here, it will see that, oh, these are decimal numbers, these are decimal numbers, these are a mixture of alphabets and letters, so it will just call them text. So we'll leave that, just leave the default if you don't really know what you're doing. Then this is the most important aspect, the x field. So x is longitude. It's easy to get it mixed up, and in fact you will notice that I wrote this as long_x and lat_y. So I like to do that because in the mix of working, things get mixed up and it's easy to turn down, to swap them. So I will choose my x field long_x and y field lat_y. Some people find this counterintuitive, like why should latitude be y and why should longitude be x? After all, latitude goes like this and longitude comes this way. But when you think of it, it actually makes sense. If you plot a graph, the y-axis is here, the x-axis is like this, right? The y-axis comes from top to the bottom, and the lines that you plot on this y-axis will run from left to right. So it makes sense that the latitude are the y-axis, you get it, and the longitudes are on the x-axis. Okay, so I think we have everything set, and here, since our coordinates are still in decimal degrees or latitude and longitude, so we are going to choose EPSG 4326 as our CRS. Then we click on add. It's added here. Then I can close this. Now you can see that I have all my points loaded in Kaduna. Okay, the original points I got from the original points data I got in Kwara State actually, but I had to modify them a bit so that because I'm making this video public and I don't want any issues with to avoid releasing sensitive data to the public, I modified the points. Okay, so now this means we have to go back and check for the UTM zone of Kaduna. So let's go back to here, and we can see if I zoom in on Kaduna, this is Kaduna State here, and it is in zone 32N. So I'll go back to EPSG.io and search for 32N, enter, and I'll scroll down. Okay, here we are. I have the EPSG code of zone 32N based on the MENA datum. So I'll select that. I've copied the code, so we are ready to continue. Now the trick is very simple. We'll just export, pretend that we want to export our points into to another file, like we want to export it to another file. But in the process of exporting, we are going to tell QGIS to export it into another CRS, into UTM. So while exporting, it's going to transform the whole coordinate system into UTM. So let's right click and select export. So this export is similar to save as in Microsoft Office or Microsoft Word. So you can think of this like you have, like we had here, you can decide to save it as a PDF or save this as ordinary txt file, or even the normal Excel XLSX file. So we are just saving it like into another format. So export save features as. Good. So we are going to choose the file name. We are saving it on our desktop. I'll choose this name, but I'm going to append underscore UTM at the end to differentiate between the one that's the raw file and the one that has UTM coordinates in it. So I'll click on save. The next thing I have to choose is CRS. So I'm going to click on this select CRS here. Then here I'm going to enter I'll paste the code that I copied from EPSG.io, this text 26332. I'll copy it and then just paste it here. Then we can see at the bottom here we have this coordinate system 26332. So okay, now I've chosen my coordinate system. Yes, UTF-8 encoding. Now at the bottom here we are going to select the geometry, so the geometry formats. So how do you want it to save the geometry? So this just means that while exporting our CSV into a new CSV file, QGIS is going to create two other columns or one other column depending on the setting you choose. One for the new X and Y of our UTM zone or any other CRS that you chose. In this case we are working with UTM, so it's going to create a new column to represent the X and a new column to represent the Y. In UTM, let me just mention that point. The X isn't called longitude and the Y isn't called latitude. Rather, the X is called easting and the Y is called nothing. So let me just type that out. Nothing and easting. So these are the terms for representing the X. This is for the Y and this is for the X. Okay, I'm getting it mixed up now. So X is the easting, yes, and Y is the nothing. Yeah, I've gotten that straight. Now here we are going to choose, there are so many formats. So there's WKT, which is well-known text, is a format for representing coordinates, but it's not human friendly. Computers love it because it's made for computers, but it's not really friendly for human reading. So we are going to choose as XY. Just save it as X and Y. So it's what QGIS will do is just create a column for X and a column for Y and put the UTM coordinates of each in that. Then separator should be comma, since our original file is separated with comma. String quoting, just leave everything in default and add saved file to map. We won't check that, so just click on OK. Good. So the layer has been exported. Let's check our desktop. So we have the file here. This is the new file that was created. We can double click it to view it. So on inspection we can see that we have the X and we have the Y, and you can notice that in UTM the numbers are very big, but in decimal degrees or longitude and latitude numbers are very small. Now let's try to import this file back to QGIS and to verify, just to verify that our whole process worked out well. So open QGIS and go to layer, add delimited text layer, then choose this. This is the output that we just created. Now open. Now we are going to choose, okay, QGIS is smart. It has selected X as the X field, Y as the Y field, but now we are not going to be using WGS 84 or EPSG 4326 because remember that our coordinates are now in UTM, so we have to search for the one we just used, and this is it here. So QGIS has stored the most recently used coordinates in the most recently used reference systems in a special tab here. So I'll just select it, then okay, you can see the code here, 26332, then okay, then add. So it has been added. Let's close this, and good for us, we can see that the points lay exactly over the previous one. So if I uncheck this, I will see the red point, which is the, oh, double click that by mistake. So if I uncheck this, if I check this, I'm not seeing the red points again. Instead, I'm seeing the new points. So they are on the same spot, meaning that our conversion worked very well. So that's how to convert UTM to lat long to UTM in QGIS. Thank you for watching, and I'll see you in another video. Bye.